Hi everyone, Mrs. Below here. In this video, I'm going to be going over the Chapter 12 notes on solutions, slides 1 through 13. All right, so let's start here with slide number 2. So we're going to be focusing on solutions. Now, a solution is a type of mixture, okay? And there are two different types of mixtures. You can have homogeneous or homogeneous and heterogeneous. So homogeneous, homo means same, so it's the same throughout. So salt water, okay, the salt will dissolve in the water and then it will be uniform throughout. Versus something that would be heterogeneous is something that where we're not going to see things mixing. So like oil and water would be a good example. So our focus is going to be on solutions. So like I said, a solution is a homogeneous mixture. And that mixture is composed of a solute that is soluble or can be dissolved. So like for example, if you put salt in water, the salt will dissolve. It is what we say soluble. There are two main components to a solution. You have your solute. So I like to think of that as the stuff that gets dissolved, okay? So the particles that are in the what we call the solvent. Okay, the solvent is what does the dissolving. And I would say probably 99% of the time it is going to be water. So the solvent is usually what you have more of. If you're not sure what it is, it's what you have more of. And I would say 99% of time it's going to be water. We will get into some examples later in chapter 13 when we have different types of solvents. But for now, I would say 99% of the time it's going to be water is the solvent, and then it's going to have some type of solute in it. Again, most likely a salt because salts are soluble and they can dissolve. So like a salt, for example, would be like sodium chloride. That's a really good example. Or any other type of ionic compound, which is a metal and a non-metal. So something from the left-hand side of the periodic table and something from the right-hand side of the periodic table. So again, salts, which are soluble, they can dissolve, are made up of metals and non-metals. So metals are everything to the left-hand side of the periodic table. And then your non-metals are everything to the right. Again, using the staircase, the metalloids is that kind of dividing point. So the solute can dissolve and recrystallize in a solvent. When the rate of dissolving and crystallization are equal, the solution is what we call, it's an equilibrium, okay? So it's forming, reforming, forming, reforming at the same rate. So that's how it's kind of staying dissolved in the water. So there's three different types of situations we can have. We can have what's called a saturated solution, which means that it contains the maximum amount of dissolved solute. So if you were to put like a crap ton of salt into water, there's a point where you won't be able to add any more solute, okay? And so once you kind of reach that limit, that max threshold, that's a saturated solution. Unsaturated is when you have under that amount. So you have less solute than a saturated solution, okay? So maybe a little bit of salt in, I don't know, a beaker or a cup of water. There are ways to create what's called a super saturated solution, and this has more than the dissolved solute, okay? Yes, this can be achieved, but it has to be done in a certain way. All right, I was able to find this video here of a supersaturated solution. So again, this can be achieved by heating like water up, for example, and this guy, he used sodium acetate, which is a type of ionic compound, basically a salt, and you heat it up and then you can cool it a certain way to get it to room temperature. And this is what we call a supersaturated solution. So this has more than what you would expect to be dissolved in here. And he's going to add what's called a seed crystal. So even if you disturb this even just a little bit, or you add what's called a seed crystal, he's going to show that, like he just is going to add a little bit of that sodium acetate. There you go. You can see those crystals forming because this is a super saturated solution. So then everything that was in there, it's going back into that crystallized state and it's no longer dissolved in the solution anymore. So you can get a super saturated solution when you have more than the dissolved amount of solute than a saturated solution, but it has to be achieved in a certain way. And then the moment that you like disturb it somehow or add a seed crystal, it's gonna get out of that super saturated state. And then some other terms to be familiar with are miscible and immiscible. So miscible means it can be mixed together like salt and water. Immiscible means doesn't have the ability to mix, will separate. So an example would be like oil and water, versus miscible would be like water and salt. Okay. All right, so a lot of times we're going to be talking about solutions where we have a liquid like water and then some type of solute dissolved in that, like salt or whatever. So a solid and a liquid. There's a lot of other types though. So our focus is going to be solid solutes with liquid solvents, but that's not to say you can't have other combinations of solutions or like homogeneous mixtures. So you can have a gas dissolved in a gas, oxygen and nitrogen, that is air. Most of the air that you actually breathe is nitrogen gas, like a huge portion of it is. And so technically the nitrogen would be the solvent and the oxygen would be the solute because there's more, again, the solvent's what you have more of. Carbonated beverages, soda, seltzer water, that's a gas, which is CO2, which is dissolved in a liquid, which is water. And then soda, you just add like sugars and syrups to it to make it into soda. Liquid in a liquid, you could have like, I don't know, alcohol dissolved in water. Liquid dissolved in a solid. So this is a really good example is if you've ever had a cavity and you've had to get it filled. Mercury in silver and tin. So mercury is usually a liquid at room temperature, and then you have solid silver and tin, which is Ag and Sn. That's actually what is in these things when you get a cavity filled at the dentist. A solid and a liquid, like I said, this is going to be our main focus. And then you can have a solid and a solid. That's any type of metal alloy. So like steel is a really good example. It's just a mix of a bunch of different metals dissolved with each other. And again, whatever's the solvent is what you have more of. The solute is what you would have less of. Gold is a really good example. Pure gold versus, so like 24. So this is the difference between like 24 karat and 14 karat gold. Again, it's not like a good or a bad thing, but it's like gold is a very soft metal. So that's typically why when people get jewelry or something, it's going to be mixed with some other types of metals so that it can not be so soft and like malleable and, be more durable, so to speak. All right, next we're going to talk about electrolytes and non-electrolytes. So again, this has to do with really ionic versus covalent, going back to one of our previous units. So electrolytes, which you've probably have heard of in like Gatorade, things like that, they are important in the human body. We're going to be talking about them in the context of like outside the human body. So these things can conduct an electrical current. Okay, and that's because when they dissolve, these are ionic compounds, and they can dissolve or what we call dissociate. So when sodium chloride dissociates, it will turn into its individual ions. These ions have a charge. This is why if you have salt water and use like a light bulb, you can conduct an electrical current through it. And it's because this ionic compound, which is made up of a metal and a non-metal, when they separate into their individual ions, one has a positive charge, one has a negative charge. This is what allows that electrical current to be conducted. And so this is why it's important in your body in terms of like your brain function, stuff like that, to have electrolytes in your system, because that helps with sending electrical impulses. Non-electrolytes are things that don't conduct an electrical current. They are going to be nonpolar, and they don't dissociate. So glucose, which is sugar, is a good example. It's C6H12O6. This will just stay in this form. It won't dissociate or break up when it's in like water, for example. All right, so I'm going to leave you with this. So I'm going to finish the rest of the notes in the next video, but try to answer this question before you go to the next video. Why does a soda get flat when you leave it open? So think about what we talked about here with that example of soda. What is happening that's causing the soda to get flat?